All right. Hey, everyone. Thanks for coming. My name is Soam Vasani. I work at Platform9. And I'm here to talk about Fission, a serverless functions or functions as a service framework for Kubernetes. So I read this tweet the other day, and I just had to put it up on. So basically, what it says is serverless means using somebody else's Kubernetes cluster. And I kind of agree with that, don't you think? It makes sense, because if somebody else is managing all the nodes for you, and all you get is an API endpoint that you can deploy anything to, isn't that serverless? So what else do you need? So I think Kubernetes has created a great platform that you can deploy software onto. But I think there's a couple of things that we can improve as soon as we have our slides back. No pressure. Should we try that?
Is that a Marco? Be right back. Sorry about that.
Okay. Just it's like those old TVs. Yeah. I don't have a whole lot of words, so just read fast before it disappears. All right, so here's a picture of a container. but really, so I want to talk about containers as about the workflows itself that we have around containers. They created great workflows around operations. They made everything uniform. You don't have to worry about virtual env in your production environment anymore. Every single thing is a Docker container, whether it has Python or Node or whatever running inside it. But the development workflow got heavier and somewhat more complicated. You now have to everyone here knows containers very well probably. So try to imagine the time before you were so familiar with containers. You had to learn how to build containers. You had to learn what Docker registry to use. You have to figure out what container image format to use. You have to figure out how to version your containers and so on. So there's a certain amount of development process weight that's added by containers. And so that said, can we have the benefits of the operational uniformity of containers and still have a lighter weight development process? So hold that thought about containers for a second while we switch subjects to resource allocation. So as we split our cloud native world into lots and lots of tiny services, we end up with a lot of services that are very rarely used. But every single service that you deploy needs a certain minimum memory usage. And if it's idle, it's not consuming so much CPU, but you have to allocate it. And so if you deploy a lot of these services, you have to account for your cluster capacity as a function of how many things you deploy rather than how much your services are used. And so can we have more of cluster capacity as a function of usage rather than deployment size? So 2 questions. Can we have lighter weight development processes around a really operationally simple thing like containers? And can we have cluster capacity as a function of actual service usage? I guess we're just going with these slides. Hold on. I'm going to try to live fix this thing. Give me 1 second, folks. Okay. Yeah. All right. Well. Okay. So since this talk is about functions as a service, the answer to that question is, of course, functions as a service. So I'm going to try and define it somewhat. So we have short-lived stateless functions, and And functions is in quotes because they're not strictly functions. They can also be modules or packages in whatever language you're working on. And that function is associated with an event or a trigger of some sort, like HTTP or a timer or something like that. And these functions are only activated when that trigger fires, which means your resource usage is proportional to the actual usage of the function. And since your function can't be running all the time, but it has to be started on demand, it needs to start quickly when you do want to start it. And so you need to have some sort of fast cold start for functions where a cold start is when the function has never been run before or was killed due to being idle. That time needs to be pretty fast. So we come to defining Fission. So Fission is a open source functions as a service framework that works on top of Kubernetes. And as a Fission user, you see three core concepts. Functions. They're a function or a module in various supported languages. And environments. Environments are the runtime dependencies of the function. Environments are also the only language-specific part of Fission. Everything else is language agnostic. And so there's a Node environment, a Python environment, a Go environment, C# and Java are also being developed, and there's PHP as well. And of course, triggers are the events that activate your functions. So today there's HTTP triggers, and you can also trigger functions based on Kubernetes watches, and we'll see a demo of that today. So you can fire a function when something on your Kubernetes resource changes. So you can watch a set of pods or services and so on. So I want to talk a little bit about how Fission works. Fundamentally, to get a fast cold start, you need a pod that's already running, because you don't want to have the time to pull an image, and even if an image is already pre-pulled, the time to schedule and allocate an IP address and start a Node or Python server can easily exceed whatever cold start tolerance you have, which is typically somewhere between 20 to 100 or so milliseconds. So if you want a fast cold start, then we need a pool of already warm containers that already have a server running in them, and we just need to be able to load functions on demand. I'm going to talk a little bit about the components of Fission and how we achieve that. So the user deploys the Fission API on a Kubernetes cluster and has a Fission client. I'm going to represent the functions that they create with those little colorful circles. They upload those functions to the Fission API. Fission has a pool manager, and this is what creates that pool of functions. So, that pool of environments. So each function is associated with some environment, so Node or Python and so on. And for each of the environments that exist, a pool of generic pods is created that's capable of running any function in that language. And then there's a router, which is where, of course, the requests come in. So let's say an HTTP request comes to the HTTP router. As soon as the request comes in, that sort of cold start clock is ticking, and now we need to quickly provision a pod with that function. So let's say a request comes in for that purple function. Then the router talks to the API and figures out what function is associated with that request. That thing is actually cached, so it's often pretty fast. It then requests the pool manager for a function pod for that function. And the pool manager creates that pod, gives it to the router, and the router proxies the request to that pod. So that typically happens in about 100 milliseconds or so. It also depends on the startup time or the load time of the function itself. The bigger it is, the more dependencies it has, the longer the startup time of the function. And so that continues for other functions. They're pulled from the pool. And as you take out function pods from the generic pool, we actually use a deployment and a replica set to create that pool. So it gets replenished when you remove function pods from it, so that we're ready for the next functions to be taken out of those. Those pods are cached for a while, even when there are no requests coming in for a few minutes. And after a certain amount of time, that's when those pods are idle, they're killed. So your resource usage goes back down to what it was before you got these function calls. Okay, so that's pretty much how Fission works. There are other components for actually watching Kubernetes, but this is the basic flow of HTTP requests and functions. So let's move on to what you can actually use this for. We see sort of 3 use cases, and such fast frameworks are good for writing really small REST APIs and webhooks. Webhooks are basically an API with one endpoint. And they're also really useful for writing Kubernetes watch event handlers. And we'll talk about that in a bit. But Kubernetes watches today require you to use one of the client libraries and write a pretty significant amount of code to keep track of some sort of Kubernetes resource. So you can do that pretty easily with Fission. So let's move on to a few demos. We have gets to 10. So I'm just, okay, I lost mine. Okay, now you can see it. All right. So I have a Kubernetes cluster here. And it has 3 nodes. This is running on the GKE EU region. And we have the Fission services deployed already. So you can see the router, the pool manager, and the API server. And Fission has a CLI that's already mapped, that's already configured to talk to this cluster. So we can look at the environments that already exist on this cluster. So we have Node and Python already set up. But if they aren't, you could have created one with this, and you can just specify an image. So you could create the Go environment with that. And you can choose what environments you want in your deployment according to what languages you're actually using. Okay, so let's create a simple hello world function. I'm going to clear and go back to the top. So we have, okay. So we have a really simple hello world. And we'll map it to, we'll create a function and map an HTTP route to that and see how long it takes to actually activate that function. So let's see. So we point this function to the Python environment. And now we create a trigger for that function with HTTP routes. Hard to type while looking backwards. Okay, so for this demo, I'm just going to curl it. So we created a function so far, just a second, and nothing is running yet. The function is just stored on Fission, and root has been created. The router is exposed as a Kubernetes service on this cluster with Google's load balancer, so we can hit it directly using that IP address. So let me just do that. Okay, so the first one, so you can see, oh, that's time. Okay. When you don't have highly variable Wi-Fi latencies, what you usually see is, what you usually see is that the first one takes 100 or so milliseconds, and the next ones take around tens of milliseconds, depending on your real latency to wherever you've deployed Fission. And the first one is where the cold start overhead actually shows up. And the subsequent requests are really just fast routing to existing instances. That's as fast as talking to a Node.js or whatever server on a Python server on Kubernetes. You had I can take a couple of questions, but I want to move on to the other. Yeah.
Just a quick one.
Yeah.
Does Fission call main by convention, or how does it?
Right. So there is it calls. So there's a specification. There's a interface that each language environment has from that Fission expects. And so for Python, it's main. For Node.js, it's the main export of a module, and for Go, it's the default HTTP handler, and so on. So whatever is idiomatic in each language. Yeah.
Good question. The pool manager, does it get created when you created the environment, or does it get created?
The pool manager is a Fission service. And are you asking when the pool is created? Yeah, the pool is created when you do Fission environment create. It's also possible to lazily create the pool only when you create a function that uses the environment. We could do that as well. Yeah.
What environment do you support apart from Python?
Node.js, Python, Go, C#, Java is under development, and I'm missing one, PHP. Yeah. Okay, so I want to show you, so we talked about heavyweight development processes, and I wanted to show you a little bit about how easy it is to change a Fission function. You wouldn't do this particular thing in production, but you can just edit your function, and it's just, right? And it's easy as that. But the point is that even if you don't edit it in place, you probably have source control and so on, but you can very easily deploy new functions without going through the whole loop of building a container, uploading it to a registry, finding a new version, pulling the image, and so on. Okay, so let's go to a slightly longer demo. So one benefit of running a FAS on Kubernetes as opposed to its own cluster is that you can interoperate really well with other services on Kubernetes that don't necessarily fit the FAS model very well, right? Because any non-trivial solution is going to have some kinds of services that fit well into this short-lived, deployed on-demand FAS model, and some services work much better when they're long-running, such as Redis. There's no point restarting Redis all the time because it really operates in memory. So here we have a little Guestbook app that stores its state in Redis and has a couple of endpoints, a get and a post method. The get retrieves the Guestbook from Redis and generates a web page. Let's see if I can show you the code. Yeah, okay. Okay, so there is two functions, add and get, and there's a Redis YAML, which is a standard Kubernetes deployment and service, and there's a shell script that deploys all of them. And the get function, what it does is it grabs a connection to Redis simply by name. You can use the standard Kubernetes service discovery stuff, reads the Guestbook and outputs HTML. Since it's just a little toy app, we have it inline, but obviously you would do more complex things when it's a real app. So let's deploy this on our Fission cluster. I'm just going to run that deploy script. It creates Redis, and it talks to Fission to upload those two functions, and it creates routes for those functions. Oh, it worked. Okay, so so we created a get route for /guestbook, and it goes to guestbook get, and a post route which goes to guestbook add, and both of those talk to the same Redis instance. go to that. All right, so that's the get, and there's nothing inside the Redis right now since we just deployed it. So you can add. So that hit the add endpoint, and when we first loaded this get, when we first did that reload to see that page, that's when the get function was first activated, and when I hit the add button is when the add function was first activated. So they're fast enough that you can just that you can build a REST API that a user can see, and the user doesn't usually notice the cold start latency. And so yeah, let's add things to it, and you. Yeah, it is accessible, so feel free. Yeah, so that's good, actually. I was going to open it in a different tab to show that it's not a client-side trick, but it obviously isn't. All right, so the same story with changing the guestbook. You can change functions. Right? And we can choose right? And hey, I'm surprised at myself that this didn't do anything. Oh, I called escape. Okay. Well, thanks for the free pen test. All right, so that's the guestbook. I have one more demo. We have 8 minutes left. Actually, 8 plus 5, 13 minutes left. Okay, good. So this demo is a little tricky, so I already have it deployed. But I wanted to show, let's see. Okay. I wanted to show the feature where we can watch Kubernetes events and trigger functions from that. So function get. So this is already deployed on the cluster, I think. And you don't have to understand all this code, but basically this is the interface that you get when you wire a function to a Kubernetes event. We send the event and object type as headers, and the body of the request is a JSON serialization of the Kubernetes object that changed. So you can deserialize it and look at pod and service data in any language you want. So this one's obviously Python. And what this does is it summarizes the state of a pod. It looks at the individual container states and figures out whether they're running or waiting for an image and so on. And it sends it to a little server that I have running here that then sends server-sent events to this web page. So the idea is to be able to watch pods from a web page. So I have no idea if this will work. So we have some existing pods, and so so that pod watcher function that you just saw is mapped to look at all pods in the default namespace and call the pod watcher function. So you can just do Fission watch create to create such watches. That one's already there. So let's actually make some pods so that that thing will get activated. Oh yeah, I always get this. Okay. Well, so that creates a deployment, which creates a replica set, which creates a pod, and well, that worked pretty fast. So this thing got that event and drew that thing, and that's supposed to represent a running pod. So let's create some more pods. Right, so the first state is container creating, and then they change to running pods. So they're container creating, they're new, and then they become running pods. And then we can, let's see, you can delete the deployment. So obviously this is a sort of silly controller. But you can write real behavior, like I heard of a user who was using this to watch services and wire them up to their internal load balancer using F5 or something. And anytime a service with a certain annotation was created, they would call into their load balancer API and create some sort of entry for that service. So normally you'd do that by writing a specific controller, maybe an ingress controller. But it's really easy to just write a function, especially in one of these languages that you may be more familiar with. So that's it for my demos. I can talk a little bit about the project status and roadmap, and then we have time for some questions. So it's back. Let's try this. Wow. That's kind of. Wow, okay. Well, maybe I'll just turn my laptop screen around and make the font really big. Geez, I have like one slide left. Well, I give up. So we open sourced at the last KubeCon in Seattle in November 2016. Since then, we've got decent traction. There's 1,600 GitHub stars for what that's worth. We're in early alpha. We intend to beta around mid to late this year. There's a bunch of things we need to do despite it works well for these demos, but we have, when you're doing functions as a service, you need better observability and things like that because we're actually creating and destroying pods. So we recently added log aggregation built in. So we create fluentd for each as a daemon set and pipe the logs to whatever log aggregation thing you're using. And if you aren't, then we can use InfluxDB. So there's various improvements that are coming to sort of improve the development and operations workflows. And there's, so that should be mid to late this year. That's fine, thanks. And the community has contributed a lot. The Go, C#, PHP, and Java support all came from the community. There's a web UI being developed. And lots of bug fixes. So thanks to the people who did this. If any of you are here, thank you. There's a bunch of stuff on our roadmap. We're improving the power of environments. You today only can do single files. So we're adding packages, compilation. Because today, even though we support Go, you have to build it on your own machine and upload a plugin. We're integrating with one or more event queues. There's a whole bunch of work around the API, and I'll dive into it more. Their documentation on the GitHub repository. We're adding metrics, tracing, support for other Kubernetes primitives, volumes, secrets, config maps, and so on. So I want to stop and not go into too much detail there. We're fully open source. There's no closed source component here. We're on GitHub, there's a website, and come talk to us on Slack, and check us out on Twitter. And we have 5 minutes for questions. Let's go from here. Yeah.
The previous talk here was about kubeless.
Really?
So how does this compare? Is there any effort to unify them?
I did talk to Sebastian. Yeah, I hope we can work together. I don't know how that'll go. It's early days for everything in serverless, I think. Yeah, I think people who attended both talks, maybe you can write a blog post and help people compare. But yeah. Someone here. Okay, go ahead.
When you create a function, where is it getting stored?
Yeah, so today it's stored on a persistent volume. The API server just directly talks to that. We're working on splitting that out into a separate storage service, which will have pluggable backends like S3 and all that.
How do you manage your dependencies in your functions?
Yeah, so today you have to rebuild the environment image. So with each environment, we have a README that says, here's how you add dependencies. For the Python environment, you edit a requirements.txt and rebuild the Docker image. We're also working on automating that and packaging dependencies with the function itself. So you'll be able to upload a zip file and things like that. Yeah.
2 questions actually.
No, you only get one.
Would it be possible to chain multiple functions, like directly without going back to the client?
Today we don't have any kind of first-class Fission function call that the function itself can do, but you can hit the HTTP endpoint of the router.
I guess this answers also my second question, which would be, can you have like function multiplex such that there are multiple functions triggered with one event?
Oh, that's an interesting use case. No, nobody's asked for that yet, but yeah, I see what you're saying. No, it's something we could add if you're, if there's interest. Hey, you already. Sorry, let me take questions. Yeah.
How extensible is the kind of incoming side of the read? How easily can I write my own router which supports my customer messaging?
It would be easier to talk to the router than to replace it, but you could rewrite the router. Each of those, if you go back to that picture, the router calls the Fission API and the pool manager's internal API. So you could duplicate that, but the way we did the Kubernetes events, for example, is to just write a separate service that watches Kubernetes events and feeds them to the router. So it's easier to just feed the router. We are also adding message queue support, so that will make it easier to just send events into a queue, and then that'll be more generic.
How do you support languages that have to be compiled?
Today, the user has to compile them. So we give the user a container that they can use to compile, or you can just compile it locally. And for Go, we use plugins. For Java, we use a jar file. Yeah, those are the 2 compile languages. Yeah. Yes?
Considering you have like a set of pods for environments so that the function can be launched on them,
Yeah.
how do you handle things like memory limits and CPU limits?
Yeah, that's a tricky one because, so today we don't. There's a Kubernetes feature in very early stages called vertical pod scaling, where you can change the limits of a CPU and memory. So it's hard to increase the memory request or CPU request of a running pod, but you could always reduce it. So a function could carry a CPU and memory limit, and the environment pods could be run with higher limits or without them. And as soon as the function is scheduled into those pods, we could tighten that limit. So your question goes into a more general question of the way we're using pods. We're dropping functions into them, and in some sense, we're changing what a pod is after it's run. So there's various things that we might have to try and make more dynamic, and we're sort of in touch with Kubernetes community, and we'll talk to various SIGs about, say volumes, for example. Today you can't mount a volume in a running pod. You have to restart that pod. So for us, the options are you can just you can have the volume already mounted, but then what happens to volumes that can only be mounted in one place, and so on. So our volume support is not very good. So that's on our roadmap too. Okay, this is a long answer. Yes.
Do you have any plan to look some kind of authorization?
Did it authorization? Yeah. So again, more generally, the question is how to do more complex API gateway stuff. And you mean for the functions, right? For the users' functions, right? So we want to be able to integrate with existing API gateways, either using Kubernetes ingress or by talking to their APIs. So there's Traefik and Kong and things like that. So we're working on this thing where you can add you can create an ingress resource when a function root or when a function is created, and you can map that to the function, and then your ingress controller can support things like that. And if there are no other questions, thanks very much for coming.